Good morning, my dear students. In today's class, in the chapter friction, we'll discuss some numericals related to the different types of the frictional conditions. Let me start the class. Questions may appear lengthy, but if you can apply the the basic ideas, no, it'll be quite easier. So it's telling there's the mass of blocks A, B, and C are 1 kg. No, so there are the mass of blocks are A, B, and C. Or 1 kg, 2 kg, and 3 kg. The coefficient of friction between contact surface of blocks is 0.5. This is smooth. This surface is smooth. This is smooth. So here between them is there. So first we'll calculate the what are the limiting frictions. So limiting frictions, where do it will come? Between A and C and between B and C. So getting the limiting friction now. Okay, this is about. Okay, anyway, let me read the question. So he has given the columns like 1, 2, 3. What to do here? I think these are some very popular questions that are there in the JEE Advanced. So if you go for JEE Advanced, no, there they are asking questions of these kind. I think if you look at all the matching list, 3-column matching list, they are called as. The questions will be very easy and students need patience. Same, this problem also may look here sometimes so much of data, but it can be easily analyzed. So first, what are the limiting frictions? FAL 5 Newton. This will be FBL 10 Newton. Okay, anyway, we'll calculate here. Let me have that data. FAL is equal to mu MAG. So mu is equal to how much? 0.51 into 10 pi Newton. The block B is 10. 5 2 ja 10. This will be 10 Newton. Okay, these are the limiting frictions. So first you start to see here now. Don't go for trying to match. Directly pick up this. Okay, column 1. See where it matches here. I think this will be on safer side. Take column 1, list 1, and try to match. Don't check this one. Don't do like this. First, okay, sir. Like, shall I check this option? This option? No. First for column 1. Okay, for the one situation 1. So what is the situation like here? 6 Newton, 1 Newton. Here 5 Newton. What conditions will arise? That will check it here. So here the first case is what I brought it here. So what is the first one is this is F1 6 Newton. The same from previous one only. This is 6 Newton. Six Newton, 1 Newton, 5 Newton. What is the net force acting on system? Towards right, 6 plus 1 minus 5. So what is the acceleration of system? I'll assume that no slipping occurs at all surfaces. I'm assuming. So 6 plus 1 minus 5 divided by total mass of system 1 plus 2 plus 3. Okay, this will be 6 plus 1, 7, 7 minus 5, 2, 2 by 6, 1 by 3. Let's go and check the frictions acting. So who will accelerate the block A? The static friction Fa. So Fa should be equal to mass of the block is 1 kg. 1 into A naught. Mass of block A. This is a data, no? Okay, now look at this 1 by 3 Newton. It is in fact less than FAL. FAL is how much? 5 Newton here. Look at here, FL is 5 Newton, but how much it is less than FL. Then similarly we'll calculate FB. FB minus 5 Newton equal to MB into A naught. Mass of the block B is 2 kg. I'll calculate FB. I'm getting less than FB. So what I assume that no slipping occurs. No slipping occurs between blocks. No slipping occurs. And what is the common acceleration? 1 by 3. Okay, now come back. What we do is like a okay, now we'll come back and we'll check it. So what is the condition? No slipping occurs between the blocks and the common acceleration is 1 by 3. All the blocks will have common acceleration and that is equal to 1 by 3. Slipping occurs between blocks B and C. No slipping occurs between B and C, no slipping occurs between A and C. So this is ruled out. Slipping occurs between A and C. So these two are ruled out. Blocks A and B collide, nothing. In which position they are, they'll be like that only. So all three blocks will have common acceleration. So can we pick up this? So 1s1, 1s1, 1s1. Okay, this is our suitable option. We'll go for it. There's a way of matching the list. Now similarly we'll check for the condition. F1 3 Newton, F2 20 Newton, F2 here this is 20 Newton, F3 this is 10 Newton. Okay, look at the data. We'll have that. I'll write it here. We are doing for second option. Let me arrange this. Just you need patience. I feel like such numericals, no, you just you need patience. Okay, we are discussing the second situation. Let's get into. This is F2. F3 and this is F2. So what is the total acceleration? 20 minus 3 minus 10 by 6. 7 by 6 is acceleration. So now Fa minus 3 Newton equal to mass of the block A is 1 kg. Already we have data. Look at here. Let me calculate Fa. It is less than limiting friction. FL already they have value. Please look at this data. I think this is what we are using in all the numericals. It's already in all the options. Fa minus 3 equal to 1 into A. Okay, there's no slipping between block A and C. There's the meaning of this. No slipping occurs between blocks A and C. Now we'll come for the block B. 20 minus FB equal to 2 into A. We'll solve for FB. I am getting greater than FBL. What is FB? 53 by 3. Definitely it is more than 10 Newton. More than 10 Newton. So slipping occurs between blocks B and C. Okay, what is the condition we can pick up here? Second one. slipping occurs between block B and C. For this data, slipping occurs between B and C. Blocks A and B collide, not possible because the B will move towards left. Not possible. All the blocks will have, so this also ruled out. Next, after this, what about the accelerations? Acceleration of block A. Acceleration of block A is not the acceleration of block B. How much? 5 meter per second square. So this option is what? Matching. So for second one, P and 2. Other things you check it, they're not applicable, no? Directly I got that one. So now I think F1 equal 2 Newton. Very easier this because you are pulling the whole system by only this force F1. Definitely no slipping occurs at all blocks. Yeah, straight away. Then check the acceleration of the system. Will be 1 by 3. So how come? Okay, we'll do one thing. What about the force? The force is acting only on the F1 2 Newton. Yeah, this 2 Newton. Only on the block is what I applied a force. Then let's assume that no slipping occurs between the blocks. The acceleration what I got is 1 by 3 meter per second square. Then F1 minus Fa equal to 1 into A. 2 minus Fa equal to 1 by 3. Fa equal to 5 by 3. It is less than FL, no? FAL. Then what is FB? FB equal to 2A 2 by 3 Newton. Remove this. So what is the conclusion? No slipping occurs between block B and C, blocks A and C. This is the third case. So for this one we have situation this and what about the acceleration? Acceleration will be 1 by 3, no? So what is the acceleration? Yeah, 1 by 3 it is. So therefore it will be 3s1. 3s1. So what about other options? It's only one option is correct. Others you need not to verify. Let's come for this one. One more case. 3 Newton force is applied. If I apply 3 Newton force, we'll see that. I don't have place. I'll do it here. And the last one will verify. Three Newton force is applied. We'll assume that all will have same acceleration. Because other forces are zero, no? Only 3 Newton force is applied. F2 and F3. Okay, this is zero, no? 3 Newton force is applied here. So let's have all the blocks will have common acceleration. We'll calculate the friction forces. Mass of the block is 1 kg. Less than FBL. Similarly, FB equal to MB into A. 2 into 1 by 2. 1 Newton less than FBL. So what is the conclusion now? FA less than FAL, FB less than FBL. So no slipping occurs at all. And B and C. Let's check any option is there. All three blocks will have same acceleration. Okay, fine. All three blocks will have same acceleration. But what is the biggest problem is like, what about that acceleration 1 by 2? What we have here is, we don't have option here. So then, so why they're given? That's what, unnecessary. So it's not that this options you have to check it. I think, are you getting now? So how to deal with such problems is like, don't check individual options for each question. I think you'll be doing this problem 1, 2, 3, 4, 12 times. No, you have to do just 4 times. 4 cases you have to analyze. What answer you get it, based on that answer, now link this list, match the list, then come and pick up the option. So you check it, all other options are not matching. Let's have this one. This also very. Two blocks A and B of masses 2 and 3 kg are placed on horizontal surface. The coefficient of friction between the block A and horizontal surface 0.5, while the block B is smooth. Okay, this is telling rough. This is smooth. Okay, fine. This is a kept surface, so they are in A and B. I'll apply force, where that force will be a time varying one. The idea is very important. Look at this force. F equal to root 2 T Newton is applied on the block A as shown at an angle 45 degree with horizontal. Then is asking at T equal to 4 seconds, what are the conditions like? Hope you are able to view the list. No. Okay, read once. Read once. There's a list 1, list 2, list 3. At least, are you able to see this? Some of you are telling, so not visible. I'll make column. At least, okay, no? Read it now. Okay, I explained here. Already I pre-written. Let me go for it here. At T equal to 4 seconds. Before analyzing, let's come for this one. I applied a force. Okay, I'll resolve this force. F sine 45, F cos 45. Then the normal reaction N should be equal to mg plus F sine 45. Then mg plus F sine 45. Mg is how much? 2t, or let it be F by root 2. Mu equal to how much? F equal to mu n. Substituting, I'll get expression for friction. This is very important. Then this will become 10 plus t by 2. Now horizontal component of force Fx, F cos 45 equal to T. No, the idea is very simple here. You need not to bother for this, is enough. When the block A will shift, when the applied force is greater than this frictional force. Don't say here some sort of like a limiting, because the limiting friction varies with the time here. The adjustment is made in that way. The limiting friction varies with the time. So what is Fx equal to? T, that one. Now put T equal to 5 seconds. Put T equal to 4 seconds. Directly come for here. Look at these two equations. Just you should take help of these two equations and analyze the situation. Nothing big. Try to link that one. Put T equal to 4 seconds. Directly, let's come for this one. Put T equal to 4 seconds. What is applied? What is the net horizontal force on it? 4 Newton. Then how much of friction? How much of limiting friction? At T equal to 4 seconds, the limiting friction will be 12 Newton. So 4 Newton force, is it possible to overcome 12 Newton? Not possible. So therefore the friction acting will be static. If the friction acting static means the block A will not shift. Acceleration of block A is 0. If acceleration of block A is 0 means it will not go and push the block B. Acceleration of block B is 0. Then the normal contact between A and B should be 0. T equal to 20 seconds, 20 Newton. Here 20 by 2, 10. The frictional force is 20. Frictional force will be how much? Here T equal to 20. This will become 20, no? Oh, some. Yeah, let this be 20 Newton. Here you substitute 20. 20 by 2. This will be 20. This will become 20 and the friction will be about to shift. Okay, still it should be 0 only. So this will make a correction. I will hope you are able to see the complete description of question. Motion impending, shall we call this as motion impending? Motion impending means block is at rest only. So this should be static only. Then T equal to 45 Newton. Here 45 you keep it. 45 by 2, 22.5. 22.5 by plus 10, 32.5. But how much of applied force? 45 Newton. So definitely for T greater than 20 seconds, the block A will shift, will go and push the block, the normal contact. Acceleration of block A will be non-zero, acceleration of block B will be non-zero, and NAB should be non-zero. This should be some. Okay, take this one. Not visible. I'll make it bold. Okay, this I think no problem. You need not to solve anything here, just you have to analyze the data. The question I just made in such a way that you have to just analyze. Nothing is there, just you have to take care about the data here, no? 32.5 Newton. So this will be definitely 50 Newton. Now come for this one. So we have like this data. So for t equal 4 seconds, the acceleration of block A is 0. Acceleration of block B is also 0. Friction on block A is static. Normal contact force acting between the block A and B is 0. I think this is correct, no? So what all we have? For option A, P, Q and 1, 3 are there. For A, P, 2 not possible. What are the choices? Choices are like this. For A, we have PQ and also 1, 3. Now search here. For A, P2 not possible. A, P1 possible. This we have to check it. So A, P1 is possible. So round it off. Only one option is correct. Other options you need not to verify. T equal to 20 seconds. For B, what is the options? Like B, it will be PQ. And 1, 3. What we can come BP1, BP1, BQ1 not. Oh. BQ3 is possible. BQ1 is possible. AR4 not possible. This is ruled out. Okay, they're possible. BQ3, BQ1. Oh yeah, these two are possible. Okay, this one. Next, this one. 60 seconds. The acceleration of block B is non-zero. Friction on block A is kinetic. Yeah, this is possible. Any other thing? DS1. Okay, this one. Yeah. You see last condition from here. Okay, the matching list. A student must have a patience. That's all. You should have very good patience. Similarly, and I'll go for C. See what all possible. I'll check it. C, acceleration of RS. To 4. D, it will be RS you need patience, even for me also, like definitely we need patience. There's no other way. Let's take the other question. This will be quite very easy. What is the largest load? The largest load means this one. What is the largest load that can be suspended without moving blocks A and B? The coefficient of friction at all plane surface 0.3. Okay, we'll calculate limiting friction at A, 0.3 into 5, 1.5 Newton. Limiting friction at this surface between B and the ground will be 0.3 into 5 plus 10, 15, so 4.5 Newton. These two are data. Now when I suspend the system is at rest. equate forces. T minus mg equals 0 because the block is at rest, no? Then the tension, this string will become tau, tension will act here. This tension will try to shift the block B. Then the friction here Fb, this string will become tau T2. Then this block A will oppose the motion, so this will be Fa. Okay, this tension will become off T2 by 2, T2 by 2, T2 by 2. The same tension should be T2 by 2. Now this tension will try to shift the block because we are asking the largest load. Largest load means the friction acting should be here limiting friction. Here also should be limiting. The friction acting should be limiting these things. So we'll substitute it. So what is this tension T? Should be equal to Fa plus T2 plus FBL. So what is FAL? Substitute all the values. Solve it now. You'll get 12 Newton. Now, a rope rests on two platforms which are both inclined at an angle theta. You can choose any value of the rope as uniform and the coefficient of friction. Platform is 1. The system has left, right. Okay, there's a symmetry. Find the value of the TF. Fraction is asking. Means like, what does it mean fraction here? Mass of the largest possible fraction of the rope that does not touch the platform is. The rope, the part of rope which will lie on the platform, let it have mass be m2. The one which is hanging part, the hanging part, let it have a mass 2m1, because here we'll take this as m2, this is 2m1. Means you take this as symmetric line. These are very old problems, not needed, since teachers still they prefer to ask. May not be very important for none of the exams. Just for learning, okay. Some mass is there, that's all. No much about physics here. Okay, there's a rope. The hanging part, the mass of the hanging part of the rope, let it be 2m1. Mass of this be m2, this be m2. Then this is at rest. What is the state of the rope? It is at rest. Okay, no. So what are the forces? The friction will act. I'm taking this part of the rope. Friction will act F. m2g cos theta, component of weight m2g sin theta. Then string will be tau. Here is what we are defining here. On here the tension will act in this way. This tension is acting on the part of the rope which is lying on the inclined plane. This tension is acting on the rope which is hanging here. Hope everyone knows this method. You should not show tension on the segment on the rope upward. The tension should be directed here like this, because the tension at this point should always act away from the body. If this is a body, it should act away. If this is suspended, the tension will act, and it will act tangential. Go back to the definition. Tension always acts the tension always acts away from the body and directed tangential to rope. You have seen this. The basic definition is what we have defined it here. We have defined the idea of the tension is this one. That is what we are applying. So how the tension should act tangentially. So we will balance the weight of the suspended part of the rope, hanging part of the rope, 2t sin theta. 2t sin theta equal to m1g1. Let's write this at rest. No. T plus m2g sine theta equal to friction. T plus m2g sine theta. Friction equal to mu m2g cos theta. T equal to m2g, take outside, mu cos theta minus sine theta. From this, T what you can write? 2m1g sine theta. This is what I substituted here. m1g sine theta by m2 mu cos theta minus sine theta. So m1 by m2 equal to sine theta cos theta minus sine square theta. Is asking maximum fraction. So this will be maximum when this bracket term is maximum. Shall I take help of maths like this? So therefore I'll differentiate this with respect to theta. So this quantity should be maximized. For this should be maximized. Okay, then the derivative of this. So we'll go for derivative. So this will be sine 2 theta. We'll differentiate and I'll equate to 0. Now this will be derivative of sine 2 theta. So here I'll divide and multiply by 2. We'll get a condition like this. Derivative of sine 2 theta should be 2 cos 2 theta. 2 cos theta by 2. I think, yeah. I'll put bracket. Huh? No. This 2 gets eliminated. Sine square theta. Derivative of sine square theta should be equal to 2 sine theta cos theta. 2 sine theta cos theta, what you can write it as sine 2 theta. This 2 gets eliminated. Then sine 2 theta should be equal to cos 2 theta. So tan 2 theta should be equal to 1. Therefore 2 theta should be equal to pi by 4. Theta equal to 22.5 degrees. The theta, if you adjust this value of theta, now you substitute and solve it, you'll get m1 by m2. I think you have to take calculator, substitute in this equation. There's equation 1, put 2 in 1. I think you need calculators. Sine of 22.5 degrees, then sine of 45 degrees by 2, then substitute, you'll get the maximum fraction. This is what you have to do it. I'll tell you. This will become 45 degrees, no doubt. This will become sine solve it now. I'll show the complete problem. May not be it's a very old problem. When I was a student also it was there, and a long back it is a. Okay, let me end up the class. Okay kids, we had the discussion on some problems on the friction. So please do think and try to work out few more better problems. Just you have to go and start doing problem. Draw the free body diagram, try to analyze and work out. Okay, now tomorrow we'll discuss few more better problems on this one. A few more problems we'll try to analyze. Okay, thank all of you. Take care. Bye. See you.